In this lesson, we are going to write some simple chemical formulas. There were 3 documents that were sent with this assignment in classroom, and ideally you would be able to print those out. You can't, we'll work around that. Our first example is ammonium sulfate. If we're not sure about the compound, whether it's ionic or covalent, probably the best thing to do is to look back at the table of common cations and anions, and if those substances are present, then we know that the compound is ionic. And there is, in the +1 table, a formula for ammonium. Ammonium is NH4+. Then if we look down in the -2 table, there is a formula for sulfate, and sulfate is SO4 2-. So, to write this formula then, we would need to use NH4+, which is the formula for ammonium, and SO4 2-, which is the formula for sulfate. And with ionic compounds, the important thing is that we balance positive and negative charge so that they add up to 0. To make that work, you can probably see that we're going to need to have 2 ammonium ions. So anytime we have 2 or more elements in an ion, and we're going to need more than one of those ions, we enclose the formula in parentheses. So NH4 2, because we need 2 ammoniums, and then sulfate is SO4. So the chemical formula for ammonium sulfate would be NH4 2SO4. The next example is tin 4 chloride, and anytime there are Roman numerals in parentheses in the formula of a compound, we know that it's ionic, and the Roman numeral tells us the electrical charge on the ion. And Roman numerals are used when there are 2 or more different possibilities for an ion, usually cations. So in this case, you can see that there are quite a few of these cations that have at least 2 different charges. Cobalt, there's a cobalt 2. On the table there's a copper 2 and a copper 1. There's mercury 1 and mercury 2. So those are pretty common. Tin is another example. Tin 4 and tin 2. So going back to the example, this one is tin 4. The chemical formula for the tin 4 ion is SN4+. So the Roman numeral tells us the positive charge on the cation. And then chloride isn't on the table, the ion table, but if we look at the periodic table, chlorine is a halogen. It's in the 7th column, so it's 1 away from a noble gas. It would most likely have a charge of -1. If it gained 1 electron, it would be just like argon. So chloride will be -1, as would be all of the halogens. So think about this for a second. What would the formula look like for tin 4 chloride? Well, to finish this up, we're going to need to have an equal number of positive and negative charges. To make that work, we're going to need to have 4 chlorine atoms, or 4 chloride ions. So the formula would be SnCl4. So the next example, we're actually going to write a chemical formula using the name of the element. And in this case, the compound is diphosphorus pentaoxide. Anytime you see the Greek prefixes in both elements, that's a pretty good clue that it's going to be a covalent compound. If we want to be sure, we can check and see where phosphorus and oxygen are on the periodic table. Phosphorus is element number 15, oxygen is number 8. Yes, both elements are nonmetals, so we're going to use the table of Greek prefixes to tell us how many of each element is present in the compound. di is the prefix for 2, penta is the prefix for 5. So we can say then that both of these elements are nonmetals. We know then that it's going to be covalent. There aren't any electrical charges to worry about. All we have to do is use the prefixes to get us the correct number of each element. So there would be 2 phosphorus atoms and 5 oxygen atoms. So in this example, again, we're going to write the chemical formula for the name of the element, iron 3 acetate. So go ahead and pause the video and see if you can write the formula for this compound. Then we'll check and see how you did. So iron is a metal. Acetate, there's no such thing on the periodic table. That tells us that this is an ionic compound. So if we look through the common cations list, we see yes, there is an iron 2, and there's also an iron 3, so both. And then acetate is in the -1 column. So iron 3 acetate then, iron 3 would be Fe3+, and acetate is C2H3O2 -1. So then again, all we're having to do is make sure that the positive and negative charges are balanced out. So you can probably see that we're going to need 3 acetates. So again, we're going to have to use the parentheses. So the formula would be Fe parentheses C2H3O2, and then we would need 3 of them. So the next thing we're going to do is practice building your brain. You all have very large brains as it is now, but we're going to make your brain even bigger by practicing. So go ahead and see what you can do with the next couple of examples for naming compounds. Pause the video. When you're finished, we'll check and see how you did. All right, let's check and see how you did. The first example is P2O3, and hopefully you notice that both phosphorus and oxygen are nonmetals. So this would be an example of a covalent compound, and we would use the Greek prefixes. So this one would be diphosphorus trioxide. So next, naming the formula NH42CO3. Well, there is no element NH4 on the periodic table. That's an indication that probably we're dealing with an ionic compound. And yes, ammonium is in the +1 column, NH4+, and carbonate is in the -2 column. So we know that this compound then would have to be ammonium carbonate. So the formula PbOH4, Pb is the formula for lead. So if we go to the periodic table and find lead, it is a metal, and that indicates to us that this is an ionic compound. So there are 2 different charges for lead. There's lead 2 and there's lead 4. Hydroxide is OH-. So again, we can use the charge on the anion, OH-, to help us decide which ion of lead is present. So if we have 4 of these hydroxide ions, that means we have a total of 4 negative charges. So the lead would have to supply 4 positive charges to balance out the hydroxide ions. Therefore, this would have to be lead 4 hydroxide. So our last formula example is CF4, carbon and fluorine. So if we look at our periodic table, both carbon and fluorine are nonmetals. Therefore, this would be an example of a covalent compound. We would need to use the Greek prefixes. The prefix for 4 is tetra, so this would be carbon tetrafluoride. Well, just want you guys to know that I miss you. I hope life is good for all of you. and I hope you have enough information now to finish up Chemical Formulas Brain Twister. If you have any questions, please don't hesitate to drop me an email note. I'd be happy to help you with it. So drop me a note and I'll get back to you as soon as I can. And good luck.